Dear students, please ask your friends to join. Sorry for this inconvenience because my licensed Zoom is being used. My friend's licensed Zoom I used to use, but which is being used by the prayer meeting. So I'm using my personal one, which is being cut for every 40 minutes. And then there is 8 minutes break. Just a few more problems and then we can conclude today's meeting. Okay, we go to the next problem. See, in a reaction, A plus B giving product. The rate is doubled. Rate doubled when concentration of B is doubled. And the rate increases by 8 factor. It is 8 times faster when the concentration of A and B are doubled. Now you find out the order. Now you find out the order with respect to A and B, or the question may be asked us to find out, to write the rate law. See, rate is equal to K into concentration of A into concentration of B. We do not know the order with respect to A and the order with respect to B. Therefore, it is X comma Y. K, A power X and B power Y. This is a general equation we have written. So the rate becomes 2R, that is doubled, when A remains the same and B is doubled. And it becomes 8R when A and B are doubled. Now we have to find out what are X and Y. You take the first two equations, 2R by R is equal to K A power X 2B power Y divided by K A power X and B power Y. So this and this and get cancelled, and this will get cancelled. Even B power Y and B power Y can be cancelled, but this becomes 2R by R is equal to 2 power Y. So 2 is equal to 2 power Y. Therefore, Y is equal to 1. So one factor we have found out. Y is equal to 1. Similarly, you can compare these two. 8R by R is equal to, it is K 2A power X 2B power Y divided by K A power X B power Y. So this is 8. This 8 is equal to K gets cancelled, a power x will cancelled. What remains is, it is 2 power x and 2 power y. Y we have already found out it is 1. Therefore, 8 is equal to 2 into 2 power x. So, if you bring this 2 down, it is 4 is equal to 2 power x. Therefore, x has to be 2. So, we have found the numbers x is equal to 2 and y is equal to 1. Therefore, the reaction is a second order with respect to A and the first order with respect to B. And you can write the rate law like this. Rate is equal to A into A power 2 and B power 1. So this is the rate law. This is how the rate law can be written for this particular problem. Then we see a few statement problems, and then we can conclude. I give you 4 statements, and you have to choose the one which is incorrect. This problem have you written? Is it clear? Okay. Now we see a few statement problems. I give you 4 statements. Number 1, order can be determined only experimentally. You have to find out the wrong statement. B, order is influenced by stoichiometric coefficients. Stoichiometric coefficients can affect the order. Option C, order is the sum of power terms. Sum of power terms to the concentration of the reactants expressed in the rate expression. Option D, order is always a whole number. This is a statement problem. The wrong statement is order is always a whole number, because order can be 0, even order can be fractional. Fractional ordered reactions are possible. Order can only be determined experimentally. Experimental determination of order, because theoretically we cannot find out the order of a reaction. And in a reaction, the stoichiometric coefficients, they influence the order of the reaction. That is true. And order, the very definition of order itself, it is the sum of the power terms of the reactants in the rate expression. But order need not be whole number always. It can be 0 or it can be fractional. Mostly, the fractional ordered reactions are found only in heterogeneous reactions. Mostly in heterogeneous reactions, where the reactants are not in single phase. One reactant is in a solid state and another reactant is in a liquid state or gaseous state, something like that. then the reaction can be fractional ordered. Next problem. This is already we have seen the unit of rate constant for a zero order reaction. I have already expressed this one. The general unit is mole power 1 minus n liter power n minus 1 per second. Actually, this has come like this. Concentration power n by second. Concentration is mole by liter power 1 minus n per second. So it is mole power 1 minus n liter power n minus 1 per second. This is how it has come. So you can find out the unit for rate constant for anything. So this is another interesting problem. You have a table is given. Let us work out this problem also. See the kinetic steady 2a plus b giving c plus d. In the first run, this is A concentration expressed in mole per liter, B concentration expressed in mole per liter, and this is rate of formation of D. Rate of formation of D. Some 4 cases are given. First, this is 0.1 mole per liter. This is also 0.1 mole per liter. Rate of formation is 6.0 into 10 power minus 3 mole per liter per minute. Mole per liter per minute. And in the second case, 0.3 mole per liter is taken. 0.2 mole per liter of B is taken, and the rate of formation is 7.2 into 10 power minus 2 mole per liter per minute. And in the third case, it is 0.3 and it is 0.4. It is 2.88 into 10 power minus 1. And in the fourth case, it is 0.4 taken and 0.1 taken, and it is 2.40 into 10 power minus 2 mole per liter per minute. So based on the above data, you have to write the rate expression. You have to write the rate expression from the above data. How to write the rate expression from the above data? Look here. First, you choose these two. For the second case and the third case, the concentration of B is doubled. The concentration of B is doubled. When the concentration of B is doubled, the rate increases by 4 times. The rate increases by 4 times. Because 4, 7, 21, 28, 4 times it increases. Therefore, it is second order with respect to B. Second order with respect to B. Second order with respect to B. When we compare the cases, one and 4, keeping the concentration of B constant, where the A concentration is 4 times increased. When it is 4 times increased, the rate increases 4 times. Therefore, it is first order with respect to A. Therefore, the rate expression is rate of the reaction is rate constant into concentration of A and the concentration of B square. I suppose you understand this problem. Is it clear? ஓடிட்டு இருக்கு. Another problem. சரி விட்டு இங்க போயிட்டு இருக்கு. For a reaction A to B, the enthalpy of the reaction, that is enthalpy, is delta H. Delta H of the reaction is minus 4.2 kilojoule per mole. The enthalpy of activation, that is EA, energy of activation or enthalpy of activation, is 9.6 kilojoule per mole. Then 4 graphs are given. Which is the correct one? This is potential energy. This is reaction coordinate. First graph is like this. Second graph, this is potential energy. This is the reaction coordinate. Third graph, potential energy, reaction coordinate. And then fourth graph, potential energy, reaction coordinate. Which graph is correct? See, this is energy of activation. Energy of activation is this. In all the cases, is this. This is the energy of activation. If you compare the potential energy of the reactant and the product, it is only in this graph the energy of reactant is high and the energy of the product is low. Therefore, this difference will be liberated. Liberated means the heat energy comes out. Heat energy comes out means delta H is equal to negative, which is an exothermic reaction. But here there is no net. Delta H is 0 according to this reaction. According to this graph, the energy of the reactant is less, energy of the product is more, so the heat energy has to be supplied. So delta H is positive here. Here also it is a large positive because there is a large variation between the energy of the reactant and the product. Therefore, this graph is correct for the given data. This graph is correct for the given data. Is it clear? Clear? Are you listening? Is it working out well? Somebody can put in the chat box. Okay. We go to the other problem. This is very interesting. The slope of Arrhenius plot. First of all, you should understand what is Arrhenius plot. The slope of Arrhenius plot. For Arrhenius plot, log k versus 1 by t is taken. Of a first order reaction is minus 5 into 10 power 3 k. What is the value of energy of activation? What is the value of energy of activation? Somebody is speaking. Sabhabadi Annamuttu. Your mic is unmute.
So you become innovators.
So k is equal to a e power minus ea by rt. So if you take ln k is equal to ln a minus ea by r minus ea by rt. When you take the log, so ln k is equal to minus ea by r into 1 by t plus ln a. So this is y, this is m, this is x, this is c. So if you plot ln k versus 1 by t, you will be getting a negative slope, where the slope of this straight line is minus ea by r. minus EA by R. So according to the given data, minus EA by R is equal to minus 5 into 10 power 3 K. 10 power 3 K. So EA is equal to minus 5 into 10 power 3. This minus is also there, therefore this can be cancelled. K into 8.314 R value, joule per Kelvin per mole. So this per Kelvin and Kelvin will get cancelled. So the answer is 41.57 into 10 power 3 joule per mole, or it can be written as 41.57 kilojoule per mole. So the next problem. For a reaction, activation energy EA is equal to 0. And the rate constant at 200 Kelvin. Rate constant under 200 Kelvin is 1.6 into 10 power 6 per second. What will be the rate constant at 400 Kelvin? See, EA is given and the rate constant at a particular temperature is given at 200 Kelvin is this. What is the rate constant at 400 Kelvin? This is the question asked. This is the question asked. See, you should know the integrated form of Arrhenius equation, which is log K2 by K1 is equal to EA by 2.303 R into T2 minus T1 by T1 T2. T1 T2. According to given data, EA is equal to 0. Therefore, log K2 by K1 is equal to 0. K2 by K1 is equal to 0. See, let me say K2 is at 400 Kelvin and K1 is at 200 Kelvin, but this is equal to 0, which means that K at 400 divided by K at 200 is equal to 1. Then only the log value becomes 0. Therefore, there will not be any change in the rate constant at 400 and 200 Kelvin. So the rate constant at 400 Kelvin will also be 1.6 into 10 power 6 per second. Is it clear? So the next one, a statement problem. The increase in the concentration of the reactants of a reaction will change A, heat of reaction, B, threshold energy, okay, C, collision frequency, and D, activation energy. Increase in the reactant concentration will never affect the heat of the reaction, because heat of the reaction is finally presented per mole. Therefore, whatever it happens, when it is calculated per mole, that will not change. And the threshold energy is also independent of the reactant concentration. Activation energy is also independent of reactant concentration, and the reactant concentration affects only the collision frequency. So collision means that the reactant molecules are hitting each other. So the collision will drastically increase when more number of reactant molecules are present in a smaller volume. So when you increase the number of reactant molecules, more frequently the molecules will collide. When you decrease the number of molecules, then molecular collision frequency will also decrease. So another statement problem. I take down this. Another statement problem. You know what is a catalyst? Catalyst is a substance which alters the rate of the reaction and remains unchanged after the completion of the reaction or at equilibrium in its mass and chemical composition. Using a catalyst in a reaction will affect entropy. What is entropy? Entropy is a randomness, internal energy, enthalpy, deactivation energy. So the use of catalyst will always affect, because a catalyst, it is a finding an alternate mechanism for a reaction to proceed at a faster rate. For the catalyst, there are two types of theories. Number one is called intermediate compound formation theory, where the intermediate is found to be highly energized and unstable. And the second one is a surface adsorption theory. The reactant molecules are adsorbed on the surface. The intermediate compound formation theory is for homogeneous catalysis, and the surface adsorption theory is for heterogeneous catalysis. That is why platinum as a bulk, if it is used for hydrogenation, or an asbestos sheet coated with platinum, which is an effective catalyst. The asbestos surface coated with platinum is an effective catalyst because of the larger surface area. Because a bulk substance will have only less surface area. But in general, the catalyst will never affect the entropy, or it will not affect the internal energy, or it will not affect the enthalpy. But it is making an alternative route for a reaction in which the energy of activation is drastically brought down. So that is how it is speeding up the reaction. So the catalyst will affect activation energy, but it is not affecting enthalpy, internal energy, or entropy. So with this, let us conclude today's class. I think the class was interesting. I will try to edit what we have recorded and try to post so that you can have them for the further reference. Right, I quit here and be online for some time.